everyone, I'm Claire, and this is a Venn diagram problem for kids. And this problem is, first we have the condition is these two semicircles are the same, and so they have a Venn diagram part, and we have a remainder part. So the problem is, and we shadow these two parts, and the problem is find the area of the sector under shadow. Okay, and so how do we solve this problem? So first we can draw a line from this point to this point. So first we are going to prove why when we line from this point to here, and we have an inception, because we know these two curves has an inception, and this line has an intersection with these two curves right here, right on this point. So we need to prove it later. But now we say what we're gonna do is I'm gonna draw another line here. So what do you find out? You see this part, we can rotate it here. So, and we can rotate this area, rotate it to here. So when we are calculating this area, we can change it to calculating this area. So that's easy. We can use this area minus this area. That's easy. But first we need to prove. Okay, so first let's see. We can draw another picture. We can draw bigger. Okay, and first. Curve. We're not very good at that. Okay, and sorry, I'll go up there. Okay, so we have a point here. So first, let's see. We can align them to a what? Line this here, and this is perpendicular. So, of course, this is perpendicular, and this is perpendicular. Because this, we align it here, right? And this is a right angle triangle, right? So this is, of course, this is 90 degree perpendicular. So what we do now? So actually we know, because this is a square, right? This is a square, so because this is the radius. Of course, right here is, these two guys are the center of the circle. This is the center of this circle. Of course, I drew not good. Okay, it should be like here. I just draw it. Okay, and this one, and this guy is, and this point is the center of this circle. Well, we can say this is a semicircle. That's fine. And so we know. And so we know, and this is here, and this is here, and of course we know. Okay. Right here we need to add some proof. So we need to prove these 2 points are the center of the circle, and this is, this angle is 90 degree, and this angle is 90 degree, and we need to prove that. Okay, and this is the intersection of these 2 semicircles. So first we draw 2 semicircles. For 2 semicircles. And you can imagine these 2 semicircles are the same. And you can imagine they are just like copy. We copy of them. And first we draw their center of the circle, and then we draw a line. Perpendicular. And right here we know we have a line right here. Okay, same. perpendicular, and then here. Okay, and now let's see. And we have this, of course. First let's see this radius and this radius, because you see these two semicircles are the same, so the radius is equal. So this radius equals this radius, and they are a segment, and these two guys, they are array. We said they are array. So first let's see if these two guys are array, and we create a superposition from these 2 points. So we can move them right here to this point, and of course this angle, when we move it here, and this angle is 90 degrees. Okay, so let's draw it. So because these two guys are arrays, so it will just happen like this. And now let's see, and now we know the neighbor lines, because this one is this one and this is this, and they're radius, so they're equal. And we know the neighbor lines are equal, so that means, okay, first, because we just said we create our superposition, and the condition is this angle is 90 degrees. And first we know this angle is perpendicular, and this is perpendicular to this line, so this angle is 90 degrees, and the same is perpendicular, so this is 90 degrees. So we know, so of course this angle is 90 degrees too. And so now we know, and of course we know the neighbor lines are equal. So that means this pattern is a square. So what we know is now this pattern is a square. So okay, this is a square. So we can imagine we just cut the expand part, because you can imagine these two, if they are an array, they can expand right here. So we can just imagine we can just cut these two expand parts. So now we have the pattern like a square, and what we do is we can change it to 2 parts, right? This one and this one. It's like this. It's like this. And this guy, because we know these two are equal, and this is perpendicular. Because these two guys are equal, and this is perpendicular. And so this part and the original two guys, because now we know this is not an array, and this is a segment too, because we just cut them, so this is a segment. And now we know this part and this part, they have the same, because they are the same pattern. Since they have the same property, because you see, what's this property out here? This angle is 90 degrees, and this segment is equal to this segment. So, and this pattern has the same property, and what is two are equal, and this is 90 degrees. So they have the same property. So that means these two guys are the same, right? Because they have the same property. So these two patterns are the same, and the same reason we can know this pattern and the original pattern right here, they also has the same properties. So they are the same too. So now actually we have proved, that means we can move this pattern right here, or you can say we move this pattern right here, and we can just create here, and that's a square. So we have proved this part. So and these are 90 degrees, so they project to a curve. So so the curve are the same. This is equal to this is equal to this curve is equal to this curve, and it's equal to this curve, and it's equal to this curve. So these 4 curves are equal. And now the next thing is we're going to prove. If we draw a line from this point, to here. And we'll draw a line from this point, from this point to here. And we improve this. This is a straight line, right? So that means this angle is 180 degrees. So what we're going to improve is, and we can draw a line from this point to here. And just draw this thing. Okay, so what we do is, that's very easy. We need to think in two parts because we have a straight line. I mean, this is a segment, right? This is a segment. And this is a curve, and they have two start points. And from these two start points, we need to think two things. So first, we think about with the segment. And from these two start points, and we draw two lines into this point. And the condition is these two lines need to be congruent, and this angle need to be 90 degrees. So we don't think, of course, so that means this point is unique. And from this curve, we can think about it with this curve, and these two start points at the same condition. We draw two lines. Of course, this is a chord, right? We draw two chords at the same condition. We draw two chords at the same condition. What's the condition? Same, right? What did you think about? What is that? Right. So, you know that, right? These two chords are congruent. Sorry. They are the same. They're the same. Not congruent. Sorry. Not congruent. Just they're the same, and this is 90 degrees. And their angle is 90 degrees. So, of course, and first they have two. They have two conditions. Let the two chords and that two lines are at the same, and they creates the same, and they creates the point are the same. I mean, so these two chords and that two line and these two lines, they are superposition. Okay, they are superposition. So because they have two conditions. The first condition is they start from the same 2 points. The same two start points is these two start points, and the second condition is they have the same condition from drawing these two lines, or you can say from drawing these two chords. So that is why. So we actually come over here, and first we know here, right? That's easy. So first we know this is a right angle. This is a right angle, and we know this is equal to this. And at the same reason, we know this is equal to this because here a line, a curve. So I still can prove that, right? So this one is equal to this one. So this equal to this equal to this, and we know this is a right angle, 90 degrees too. So 90 degrees plus 90 degrees equals to 180 degrees. So that means this one line and this line is one. They have the angle 180 degrees. So what that means is, this one. That means this is a straight line, right? Okay. So if we proved this is a straight line, so that is easy, right? So now we have this line, and this equal this, and this. So these lines project to their curve. I mean their arc, you can say, are the same. So the four area enclosed by the chord and the arc, right, are the same. So this one is this area is equal to this area, right? This out. The shadowed area and the shadowed sector that I draw is the color. Use the blue color is the blue. They are the same, right? So that's very easy. So now, So now we're gonna do is calculating. So now that means we can, because these guys are same, so we can move this area to here and move this part to here. So that's very easy. So the thing is, now we can use, because we know these two guys are A, and we just use pi to explain it. Okay? So just use pi, explain it. So what we're going to do is, the whole part is pi times a squared over 4, because this is a quarter of a whole circle and the radius is a. So pi a squared over 4. Divide 4. The minus is this part, this right triangle is a squared over 2. A times a over 2, divide 2. So, and that's equal to, we can make this function much more beautiful. So, what is that? Much more pretty. So, we can just turn them to the same denominator, and then we can factor out a squared, because here is 2 times a squared, and it's pi a squared minus 2a squared. So we're going to factor out a squared. So we can have pi minus 2 bracket times a squared. So we have solved this problem. This Venn diagram problem for kids. Okay, so we solved this problem. So we actually we solve a equation for this function, because this is a, this is a. So if you find out if this is 6, or any numbers, you can just put a number in this function and it will solve the problem. After which we just grade out firm. Not firm, just equation. See, we just solve the problem. Okay.